So here we have another partial fractions problem, and we're actually going to have a squared term and a linear term here. So this will be good practice for us. Here it looks like kind of difficult because we're going to have the x squared minus x plus 6, but it'll even out. So we want to simplify the denominator as much as possible. We already know it's going to be a higher power, which means that we can just step right into the partial fractions. So let's factor an x here, x squared minus x plus 6. And here we're just going to work on the partial fraction decomposition. X squared plus 3. We'll go through the entire integral, but this part right now is just the partial fraction decomposition. So here, this is going to have a linear term, so it's going to be a over x plus, and then we're going to have a quadratic term, which means we're going to have to bx plus c over x squared plus 3. Multiply by the lowest common denominator, which from the previous problems we know was just going to be this, right? So we're going to have an a x squared plus 3 plus a bx plus c, right, times an x is equal to x squared minus x plus 6. So here we're going to distribute our x squareds and our x. So for here we're just going to have ax squared plus 3 plus a bx squared plus a c times an x. X squared minus x plus 6. So now I just want to compare our x squared terms and our x terms and then our constant terms. So here we're going to look at our x squared terms. So we have an a, we have a b, so a plus b. There's no other x squared terms, so that would equal 1, right, the coefficient in front of x squared. And then we're going to go with the negative x terms, or the x terms. Right here we just have 1, so c is equal to negative 1. And now we have to look at our constant terms, which is that 3a is equal to 6. So here, this is actually a pretty easy solution. We just have to figure out what b is. So a is equal to 2, c is equal to negative 1. If we plug in 2 here, we get b plus 2 is equal to 1, so b equals negative 1. Now we do the integral. And we've already split it up, so it would be 2 over x, and then plus a negative x minus 1 over. So in this case, it's going to be beneficial if we split up this second term here. So let's actually split up the entire integral and we'll see what happens. 2 over x plus the integral of negative x over x squared plus 3. Here again, I've just taken this and split up the numerator, plus negative 1 over x squared plus 3. This one is actually a pretty fun integral, I'd say. So here we can, this one's going to be 2 ln of x, right? We have dx's here. This one, we could do a trig substitution, but it's going to suck, so we can just notice that we're going to have x squared plus 3 would be a good u substitution. du is going to be equal to 2x. That'll cancel out our x on top, so we're going to have minus 1 over 2. And then we're going to have a u here, so it'd be ln of x squared plus 3. And then here we actually have an arctangent, but it's not. It may not be immediately obvious. So I'll go through what exactly you would expect on the scalars for the arctangent. So here, let's pull out a. Let's just evaluate this integral here. Negative 1 over. So here, let's pull out a 3. So pull out a 3. X over a square root of 3. Right. Sorry. So here it becomes obvious that we're going to have a minus 1 over 3. And then we're going to have an x over x over the square root of 3 is equal to tangent of theta. Dx is equal to the square root of 3 secant squared theta. So now we're going to plug those in. We'll get minus the integral 1 over 3, right, times the square root of 3. And then we'll have a square root of 3 secant squared theta, right? We'll have a tangent squared theta plus 1. And this is going to actually evaluate to tangent squared theta, or is going to evaluate to secant squared theta, right? These are going to cancel, that's going to cancel. So you get negative 1 over 3. The integral of, right, secant squared theta over secant squared theta. Right, that's going to cancel, that's going to cancel. Then we have negative 1 over 3 d theta. So we're going to get negative 1 over 3. And then our theta is equal to arctan x over the square root of 3. So then our final integral becomes 2 ln of x minus 1 over 2 ln of x squared plus 3 minus 1 over 3 arctan x over the square root of 3. And here let's see. Yeah, so here I've actually made a simple mistake. So there should be a square root of 3 secant squared theta, and then there should still be the factor of 3. So it should be the square root of 3 over 3. We multiply that times the square root of 3, square root of 3 times the square root of 3. Right, this will give us 3 over square root of 2 times 3, 3. So it should be 1 over the square root of 3. Just a simple mistake, but I just had to make sure I got that square root. Oh, and don't forget our plus our constant. That's our final answer.